Hello guys, welcome back, and in today's video we're going to discuss about the reactivity series. Alright, so in IGCSE chemistry it is very important that you remember this reactivity series to actually do any problems at all. Okay, so this is very vital, very important. You must remember this information by heart. So you will notice that the metals above the reactivity series are very reactive, and the ones in the middle have medium reactivity, and below hydrogen the elements or the metals will have very low reactivity. All right, so based on the reactivity series you can actually predict whether a reaction will take place or not, and you can also guess the products to be formed on the right side of the equation. So let's take a look at this one. Okay, so explain what this reaction shows about the relative reactivities of aluminum and iron. Okay, so we can see that aluminum is higher than iron in the reactivity series. So aluminum is able to displace iron from iron 3 oxide, okay, to form aluminum oxide. But if the equation is the other way around, there will not be a reaction, because iron is um, not going to displace aluminum from aluminum oxide, because iron is lower than aluminum in the reactivity series. Alright, so let's take a look at the reactions of metals with water. Okay, potassium, sodium, lithium, and calcium, since they are highly reactive, they can react even with cold water or steam, and that is why I wrote that H2O liquid here. For magnesium to iron, right, they can only react with steams, which means that they can only react with H2O gas, while this will be H2O liquid. Okay, so notice the difference in state symbols. Okay, because based on the different state symbols, our product is going to be different as well. If you react with cold water, you will get a hydroxide, but if you react with steam, which is a gas, you will get a metal oxide solid and hydrogen. For copper, silver, and gold, they are very low in reactivity, and that is why they will not react with anything at all. Okay, and that is why in the sample here, copper plus either steam or liquid or cold water, right, there will not be a reaction at all here. Alright, so if we know about it, let's go ahead and do these ones. Okay, alright, calcium plus water, you would be getting calcium hydroxide aqueous plus hydrogen gas. Okay, as per your equation here, and try to notice that whenever you have hydrogen gas as your product, right, you would see bubbling. This is always one of the observations that you can write down. For magnesium reacting with gas, your product would be metal oxide plus hydrogen. So this will be magnesium oxide solid plus hydrogen gas. So try to take note that your magnesium oxide will be a simple white powder, and when magnesium reacts with water with steam, right, you're going to see a bright white flame. Alright, when zinc reacts with steam, you will get zinc oxide, which is a solid and hydrogen gas. Okay, so your observation here is that zinc oxide, okay, will be a yellow solid. So I understand that the colors and the observations might be difficult to remember, but if you keep practicing on it, if you take note of it every time you see something, there's no way that you are not going to remember all of this. Okay, so when iron reacts with steam, which is a gas, you will get triiron tetroxide, which is Fe3O4 solid plus and hydrogen gas, and you might need to balance your equation here. Okay, so you can do the balancing on your own actually. So triiron tetroxide will actually be a dark gray or a black solid here. Now let's take a look at reaction of metals with acids. Okay, so for potassium to calcium, since they are very highly reactive, reaction is actually not done because they are very reactive, they're explosive, and you can also say that they are very dangerous as well. Alright, so for magnesium, magnesium will react with cold dilute acids very vigorously, but for aluminum, it's going to react very slow with cold dilute acid, but then it will react with warm acids very vigorously. For zinc and iron, right, for both of these, they will react very slow with cold dilute acids, but similar to aluminum, they will react with warm acid. But then your vigor, okay, meaning that how explosive or how fast your reaction is, zinc and iron will however be still slower or less vigor than aluminum. For copper, silver, and gold, they do not react at all with acids. And let me explain something here, which is why does aluminum react slow with cold dilute acids, okay? This tiny part here, but it will react with warm acids very vigorously. It's actually because aluminum doesn't exist on its own, okay? It always has a very thin layer, as you can see here, of aluminum oxide on the surface, okay? So which means that if we have, let's say, HCl acid trying to react with aluminum, they can actually react without heating because this thin layer is protecting aluminum from coming into contact with HCl, and that is why the acid has to be heated, or you need to warm the acid, okay? So it will only happen when you apply heat, okay? This aluminum oxide layer will be gone, and only then HCl will be able to react with aluminum. Alright, so as for writing down the equation, whenever a metal react with acid, you will get a salt and hydrogen. For example, if it is dilute sulfuric acid, you will get a metal sulfate. If it is a dilute hydrochloric acid, you will get a metal chloride. So let's try to write down one example here, okay, which is, let's say, magnesium, okay? So if you react magnesium solid plus sulfuric acid, you will get magnesium sulfate, which is aqueous, plus hydrogen gas. Alright, so you can follow the same step for others as well. Alright, now in exams, a commonly asked question is giving you an unknown metal X, right? They will give you an unknown metal X and then ask you where it is in the reactivity series, and of course ask you what you would get if you react it with sorry, water or acid, okay? So let's just say, right, this is how we can do it step by step. If we're given a metal X, we will first react it with cold water, okay? And if there is a reaction, right, if the metal X can react with cold water to give any reaction, it will be somewhere here, okay, above magnesium in the reactivity series. But if there is no reaction with cold water, we're going to add it into the dilute hydrochloric acid or sulfuric acid. When I say yes and no here, this means that it is no reaction or there is a reaction, okay? So when we add it to dilute hydrochloric or sulfuric acid, if there is a reaction, right, it should be around magnesium. But if there is no, okay, reaction with cold dilute hydrochloric acid or sulfuric acid, what we're going to do is we're going to warm up the acid. And even then, if there is no reaction at all, for sure our metal X is below hydrogen in the reactivity series. But if our metal X reacts with warm acid, then we know that it is between here. Alright, so that is how you can actually find where your metal X. And in exams, after you find out the position of metal in the reactivity series, they're going to ask you to write down the products. Okay? and that is a common question that you might have to answer. So always try to follow this procedure to find out where your X is in the reactivity series. Alright, that being said, let's do some practice problem here. Okay, so take a moment to read these questions first. Alright, remember in exam the reactivity series will not be given to you. You need to be able to write these down on your own. Alright, so let's just take a look at this one. What is the order of reactivity of these metals? So what I would do is I would figure out which one would be the least reactive first. Okay, so I think W would be the least reactive because it does not react with water, it does not react with sulfuric acid. So my least reactive has to be W or W. Okay, so I can actually cross out this one and this one. Alright, so my next step, let's take a look at this. It is to find out whether Y or X is more reactive. So I'm going to compare Y and X only. So X, when it reacts with water, it's a slow reaction. But for Y, there is not even a reaction at all. So meaning that Y is lower reactivity than X. Okay, and that is why my option has to be B. And in exams, make sure that you are reading this information. Are they asking from most reactive to least reactive? Okay, or are they asking from least to most? Okay, what are they trying to ask? Make sure that you read this. Okay, students often tend to make very careless mistakes. State which metal could be copper. So copper is very low in the reactivity series, meaning that he's not going to react with acid or H2O, meaning that it is obviously W. Now, state which metal, W, X, Y, or Z could be magnesium. Okay, so it obviously cannot be W anymore. So we need to figure out which one it is between X, Y, and Z. And I think it is X because because since it is magnesium, right? If it is going to be magnesium, it has to react with water. So meaning that the no reaction with water option can be gone here. This reaction can be gone here as well. But you have to remember that in order for something to react violently, it has to be the potassium to calcium. So magnesium won't react violently, it will only react quickly. So your answer here is X. Now, a displacement reaction can also be used to decide the order of reactivity of two metals. Alright, try to clear this. So state two observations made when excess of magnesium powder is added to aqueous solution of copper 2 sulfate. Okay, so it will always be helpful for you to write down equations first. Okay, so when magnesium reacts with copper 2 sulfate, magnesium reacts with copper 2 sulfate, you will get magnesium sulfate and copper, right? So meaning what? Since copper is produced here, you will be able to see pink brown copper, okay, deposit or particles. You have to mention the pink brown, okay, because you can't just say that copper is deposited, everybody knows it. And another thing is that copper will initially be a very light blue color. Okay, copper will be a light blue color, but then copper was displaced by magnesium, so the color will change from blue, copper 2 sulfate, will become pale blue or even colorless. So if you notice here, you will notice that you have to use a lot of reasoning, okay, to actually go through the reactivity problems. Alright, pause the video and try to read the question first. Alright, so I'm gonna do it, okay? So identify which elements could be gold. So gold is here in the reactivity series, meaning that it's not going to react with water or acid. So it's not going to react with water, it's not going to react with acid, so my answer is Q here. Suggest what reaction between metal R and dilute hydrochloric acid has not done. So let's go and take a look at R. For R, it's when it reacts with water, it's going to form hydrogen gas very quickly, meaning that it's going to be one of these. And reason why we do not add this to any acid at all is because of what? Because the reactions can be explosive, okay, or it can be dangerous. Alright, so in the last question, they ask you to arrange the in order of reactivity. So our least reactive, you know that it's going to be Q, and our most reactive, you know that it's going to be R here, okay, within this one. Alright, so we need to figure out between P and S, P and S here. Alright, so for element P, right, it will not react with water, but for S, it will form hydrogen gas very quickly, so meaning that P is lower than S in the reactivity series. Again, you must use a lot of your reasoning, okay, based on the reactivity series to answer this question. You can try to remember questions and answers by looking at it. You must think, okay, you must think and apply logic to actually answer all of these questions successfully. Alright, that's all. See you in part 2 of reactivity series.